So I sent out those notes for 8.5 because we're talking about rational functions in this section. Rational functions are the functions that have the x in the denominator. And so there's just a lot of different characteristics of rational functions. Okay, the first characteristic we're going to talk about is the domain of rational functions, which is what we did in 5.1, that very last section before spring break. When you're finding the domain of a rational function, what are you concerned about? What needs to be omitted from the domain? Anything that'll make that denominator 0, right? Because you don't want the denominator to be 0 because that's undefined. So that's what you're going to do on the first couple of problems, is just find the domain of the function and enter it in interval notation. Okay, so on number 1, you have f of x equals x squared over 9 minus x. So I want to find out what makes that denominator 0, right? It can't be 0. So 9 minus x cannot be 0. And then solve it for x, which I can actually do in one step here, right? If I wanted to get the x by itself, since it's negative, I can just add it to the other side, right? So add x to both sides. So 9 cannot equal x, but it does want you to write it in interval notation. And remember what that means is I want to include everybody on the number line from negative infinity to positive infinity, except 9. So the first interval is negative infinity to 9. In union with the second interval is the other side of 9, which would be 9 to positive infinity. Okay, and I did have somebody in a class before spring break that was using the U on the keyboard and it kept working it wrong, even though everything was right. This union with symbol is in the toolbox, right, where the fractions and exponent things are. All right, number 2, same thing, finding the domain of this rational function. F of x equals 3 over x squared plus 2x minus 35. So this denominator also can't equal 0. Since it's x squared, I can go to quad and find the 2, because this one's going to have 2 solutions, right? Because it's x squared. If you go to quad and type in your A, B, and C, what's your A going to be? 1. B will be 2, and C will be negative 35. Which would give you 5 and negative 7. Okay, if you don't have quad, this is actually not a bad factoring problem, right? You could factor that trinomial. X and x for x squared. Numbers that multiply to equal negative 35. If you're multiplying to equal a negative, what is your automatic sign situation going to be? Right, you're going to have different signs to multiply to get a negative. The factors of 35 are 35 and 1. There's no way I'm going to make that equal, add that to 2. What's the other 2 factors of 35? 5 and 7. If I need that to equal positive 2, I need positive 7 and negative 5. So why are these the zeros instead of these signs? Because what do you do with each of those?
Flip the sign.
Right, you flip the sign when you set them equal to 0. Because here you'd have to subtract 7s. So x can't equal negative 7, and here add the 5. So X can't equal 5. So that's why those are the numbers that need to be excluded from your domain. It does want it in interval notation. So let's see. On my number line, who's going to come first?
-5.
Negative.
Oh, 7.
-7 and 5. So this one's going to have 3 intervals, right? My first interval will be negative infinity to -7. My second interval will be in between the two numbers. So in union with -7 to 5. And then my last number is the numbers above 5. So in union with 5 to infinity. Okay, we're actually going to skip 3 and 4 for now and come back. So the next thing we're going to talk about are vertical asymptotes. And again, I put how to find them on that notes thing that I handed out. It's the very first thing under the domain. Okay, to find the vertical asymptote, what the vertical asymptote is a vertical line where the graph comes right up next to it, but doesn't touch it. Okay, so that's also going to be found by the zeros of the denominator, which are not also zeros of the numerator. So let's see how to find these. So again, skipping 3 and 4, we'll come back later. Number 5, f of x equals 1 over x minus 4 squared. So what's going to make this denominator 0? 4 will, right? You can just set what's inside there equal to 0. Add the 4 to both sides. So x equals 4 is going to be your vertical asymptote. So if we're not going to have to graph these yet, but we will. So there is going to be, and it's represented with a dashed line, a vertical asymptote going through x equals 4. Now, I do want to also remind that it's a vertical asymptote if it's a 0 of the denominator, but not also a 0 of the numerator, which I don't have to worry about on this one, because you find the zeros of the numerator just like you find the zeros of the denominator. This one's not going to have any zeros, right? Because it doesn't have an x. Doesn't matter what you're plugging in for x, the numerator is always going to be 1, right? So in order to change it, you'd have to have a variable up there to change it. So this one, and when you enter it, this particular problem already has the x equals there for you. So all you need to put in is the 4. If it doesn't have the x equals there for you, you have to write x equals 4, okay? Because this does represent a line, a vertical line, which comes as an equation. Right? Number 6. F of x equals x minus 9 over x squared plus 8x. So this one's actually going to have 2 values that make the denominator 0. Since it's x squared, I can either put this in quad, since it's x squared, just be careful. A would be 1, B would be 8, C would be 0. Or I can just pull out the x to factor it, because it's got a common factor of x, so I can pull it out. If I pull an x out of each of those, I'm left with x plus 8 Set my two factors equal to 0. Solve them for x. So this one's already solved, x equals 0. This one I just need to subtract the 8 from both sides. So x equals -8. So those are going to be two vertical asymptotes this time, as long as neither one of these are also zeros of the numerator, which they're not. What makes the numerator 0? 9 would. So if one of these numbers was the same as that, it would be canceled as an x, as a vertical asymptote. Number 7. Again, finding the vertical asymptote. F of x equals x minus 3 over 1 minus x. So again, finding the 0 of the denominator, 1 minus x equals 0. Solve it for x. I'm going to just do it in one step by adding the x to the other side. So 1 equals x, or x equals 1, is the vertical asymptote because what's the 0? What would make this one 0? 3, and they're not the same. So this is a true vertical asymptote. Right, number 8. 8, 9, and 10 are all doing the same thing, finding vertical asymptotes. Okay, on number 8, do I need to worry about any zeros in the numerator? No, because there's not an x. So I don't need to even worry about that. I need to find the zeros of the denominator. It's like this one has just already done the factoring for me. After you factor, what do you do with your factors? Set them equal to 0 and solve them for x, which is just going to do what? Change those signs, right? It's going to turn this into a -5 and this into a +1. So your vertical asymptotes, you have 2 of them this time. X equals -5 and x equals 1. Number 9. All right, on number 9, I'm actually going to use the quad in the top and the bottom, right? Because since they're both quads, they're both x squared, there's going to be 2 zeros in the top and 2 zeros in the bottom. So we just need to make sure that none of them are the same. Okay, both of those are factorable, but since we have the quad program, we might as well use it. So the zeros of the numerator, let's see, my A would be 1. B would be 5, and C is -14. So the zeros of the numerator are 2 and -7. Now let's find the zeros of the denominator. Again, since it's x squared, I'll use quad. My A is 1. My B is -3, and my C is -10. So the zeros of the denominator are 5 and -2. Are any of the zeros in the numerator the same as the denominator? No. Which means these are both true vertical asymptotes at x equals 5 and x equals -2. All right. right, the last one where we're going to be finding just vertical asymptotes is number 10. G of x equals x to the third over 3x to the third minus x squared minus 30x. Okay, let's go ahead. Since there is an x in the numerator, let's think about what its 0 would be. What number, when you plug it in for x and cube it, is 0? 0, right? 0 to the third power is 0. So that's going to be the 0 of the numerator. So let's just keep that in mind. In the denominator, this one's x cubed. So it's actually going to have 3 values that make the denominator 0. We haven't been factoring with x cubed trinomials, but look what they all have. They all have an x, which means what can you do? Factor it out. So factor out the x, put in parentheses what's left if I take an x out of everybody. They're all just going to lose an x. So now this is going to be 3x squared minus x minus 30. So this is one of the factors. So I'll set it equal to 0. Now that I do have it down, I can go to my quad program to find the other 2. With A being 3, B being -1, C being -30. So let's put that in quad and see what we come up with for our other 2 zeros. A is 3, B is -1, C is -30. It gives me a decimal and -3. I'm just going to hit enter again because it'll turn that decimal into the fraction. So the other 2 zeros that come from this are x equals 10 thirds and x equals -3. So the denominator has 3 values that turn it into 0. But what about this one?
Cancels.
It cancels because it's also the 0 of the numerator. Okay, so they cancel each other. So the only true vertical asymptotes are those. So now we're going to talk about the horizontal asymptotes, which are horizontal, represented by the horizontal dashed lines. This is the main reason I printed out these notes, because the horizontal asymptotes go by this chart with A, B, and C, because where the horizontal asymptotes come from are by comparing the degree of the numerator with the degree of the denominator. And the degree of the numerator is whatever its highest exponent is. That's what makes the degree. Same thing in the denominator. It'll be what its highest exponent is. So the chart, so there's one of 3 things that can happen then. The degree of the top can be less than the degree of the bottom. If that is the case, that's the A situation. The horizontal asymptote is at y equals 0. If the degree of the numerator is bigger than the degree of the denominator, there's not a horizontal asymptote. So degree less than the degree of the numerator, less than the degree of the denominator, the degree of the denominator greater than the degree of the can't say this right. So the top is either less than the bottom, or the bottom is less than the top, or what's the other situation they could be?
Same.
The same, equal. which is the C situation. If the degree of the numerator is equal to the degree of the denominator, then the horizontal asymptote is y equals, you're going to make a fraction with the leading coefficient of the top over the leading coefficient of the bottom. So let's just look. It's going to give us one of each situation. Let's look at number 11, which is the first one of just horizontal asymptotes. Okay, so the first thing we want to do is see which category we go into, A, B, or C. Right, because what's the degree of the top? 2. The degree of the bottom is 2. So the degrees are equal. What does that mean? It means your horizontal asymptote is going to be at y equals, the leading coefficients are just the numbers in front of those terms. So that you can just make a fraction with that right there. So the horizontal asymptote is going to be at y equals 2/5. Number 12. F of x equals x squared minus 7 over 6x to the 4th plus 7. So the degree of the top is 2. The degree of the bottom is 4. So which category does that put you in? The top, the numerator is less than the denominator, which is the A category, right? Which means your horizontal asymptote is automatically y equals 0. All right, number 13. All right, let's find where the horizontal asymptote is for this one. The degree of the top is 3, the degree of the bottom is 2. So the numerator is greater than the denominator, which is case B, right? If the numerator is greater than the denominator, there is no There is not a horizontal asymptote. Now we're going to go back to 3. Because 3 wants us to list all the asymptotes. So for some reason, it is before learning about each of them separately. The one kind of asymptote that we haven't talked about is going to be called an oblique asymptote. We're not going to have any problems that are going to have one of those. Those occur when there is no horizontal asymptote. Okay, but we're not going to have any problems like that. So if it's asking about an oblique asymptote, the answer is always going to be there is none. Okay, so the function on number 3 is r of x equals 3 over x squared minus 49. So the first thing it wants to know is what are the vertical asymptotes, which means zeros of the denominator that are not zeros of the numerator. So look, that I can factor pretty easily. It's a difference of squares. If I did choose to put it in quad, since it is x squared, a would be 1. What would b be? 0, right? Because what is b? The number in front of the x, which there's not one, so it'll just be 0. Your c would be negative 49. But like I said, that'll factor pretty simply since it's a difference of squares. X and x for x squared. What do you multiply times itself to get 49? Yeah, 7. What are your signs? Always a difference of squares. Different. So if I set these equal to 0, what's going to happen is their signs are just going to change, right? This one will turn into negative 7. This one will turn into positive 7. Are either one of those zeros of the numerator? No. Remember, you do always need to check that. So your vertical asymptotes are x equals negative 7 and x equals positive 7. And actually, you can type it in either way, like that. This particular problem does not have the x equals there for you. So when you're typing it in, because what is the vertical asymptote? It is a line that the graph doesn't cross. Then it wants to know where the oblique asymptote is. There's no oblique asymptote. And then the horizontal asymptote. So again, that has to do with the degree of the top compared to the degree of the bottom. What's the degree of the top?
1.
No, there would be an x, so 0. The degree of the bottom is 2. So the top is less than the bottom, which means your horizontal asymptote is automatically y equals 0, which is actually the x-axis. So this does give me a multiple choice situation now where I'm trying to place the graph. You're going to be able to narrow it down to 2 graphs just by knowing where your vertical asymptotes are. But that's going to leave you 2 options. There's going to be 2 graphs that have both of those vertical asymptotes and this horizontal asymptote. It doesn't ask you to find any other characteristics, but you're going to have to in order to find which graph this is. Okay, that's why on the thing you'll look. I'm going to find the Y-intercept. How do you find what are your x's at the Y-intercept? 0. So replace all your x's with zeros, and your Y-intercept is what you have left. So if I replace my x's with zeros here, I would have what? 3 over 0 squared minus 49. Well, 0 squared is 0 minus 49. So 0 minus 49 leaves me with negative 49. That's your Y-intercept, which means this graph is going to cross the y-axis below the origin because it's negative. So the difference between the only 2 graphs that you have left are where they cross the the y-axis. One's going to cross it a little below, another one's going to cross it a little above. So its y-intercept would be positive. So these asymptotes are telling me, here's the first part, cross through there, and then here's the last part. Okay, now on number 4, there is a number 4 on this handout. There's not a number 4 in your homework. Okay, I can't remember if it'll just skip it or if it will. Remember what it did last time that I took a problem out? It just said this problem's already been, you've been given credit for it or something like that. But I think it just skips it in this case. All right, I do want to do one more just to give us a little indication of what we're going to do on Wednesday. Okay, starting with number 14. So now the characteristics that we know of rational functions are, we can find the domain of it. We can find the vertical asymptotes. We can find the horizontal asymptote. We can also find the Y-intercept, right? That's just replacing all the X's with zeros. To find the X-intercepts, that comes from the zeros of the numerator that are not also zeros of the denominator. So what I'm going to do on every single problem, starting with number 14 to the end, is find the zeros of the numerator and denominator first. That's going to answer a lot of questions, right? That's going to answer what the domain is, where the vertical asymptotes are, and also where your X-intercepts are. Okay, so let's look at number 14. So again, even though it doesn't just come out and say, find the zeros of the numerator and the denominator, I'm going to go ahead and do that because that's actually going to help me answer a lot of the questions. So zeros of the numerator, just all you're doing is setting it equal to 0 and solving it for X. So subtract 3's here. So 3X equals -3 divide by 3. So X equals -1. So -1 is the zero of the numerator. Now let's find the zero of the denominator, which that just makes, you just set the denominator equal to 0. Solve it for X, which it's already done once you set it equal to 0. So what's the zero of the denominator? 0, right? If I set it equal to 0 and solve it, it's actually already solved. Now that's going to help us answer a lot of the questions. The first question is, what is the domain of this function? Which has to do with that 0 of the denominator, right? I want to include all the numbers on the number line except 0. Which means that first interval, which would be -infinity to 0 in union with the numbers above 0, which would be 0 to +infinity. So there's the domain. Then it wants to know where the X-intercept is. Okay, and again, on your sheet, you'll see at the bottom, that second to last statement says they occur at the zeros of the numerator that are not also zeros of the denominator. This is why I did this in the front end. What's the 0 of the numerator? -1. Not a 0 of the denominator, which means there's going to be an X-intercept. It's going to cross the X-axis at -1. Now, remember, when you're talking about an X-intercept, and remember, always read the stuff in parentheses when you're typing in your answer. Because what does it tell you? Type an ordered pair, right? Because a point has an X coordinate and a Y coordinate, which is what the X-intercept is. What's the X coordinate? -1. What's always your Y coordinate if you're an X-intercept?
0.
It's always 0. That's what makes you lie on the X-axis. Now, the last thing it's going to ask is, what's the Y-intercept? How do you find the Y-intercept? Replace all your X's with zeros. Now, you're going to want to add a little statement after the statement I have about the Y-intercept for this situation here. I replace all the x's with zeros, I'll have 3 times 0 plus 3. Replace the x with 0. What's the top going to be? 0 plus 3, which is just 3. What's your denominator going to be? Where are you going to put that point? You're not, right? Because the denominator is 0. That's an undefined number. So if when you replace the x's with zeros and it turns your denominator into 0, that just means there is no y-intercept. It's not going to cross the y-axis. So let's see. I'm going to cross the x at -1. I'm not going to cross the y. That's not going to give me a lot of information. And it is going to give me 4 options to choose from. I am going to want to find my horizontal and vertical asymptotes here. Where is my vertical asymptote? 0. X equals 0, which is actually the y-axis. That's where x equals 0. The other asymptote, horizontal asymptote, what are the degrees? They're equal, which means you just make a fraction right here. Right, so your vertical asymptote was at x equals 0. Your horizontal asymptote is at y equals 3, because 3 over 1. So there's a horizontal asymptote right here. That's what's going to narrow it all the way down. Knowing those 4 things, that it doesn't cross the y, it crosses the x at -1. The most telling asymptote is this one. It's hard to see this one, right? Because it's actually on the axis, but this one I can see clearly. So that's how you're going to be able to narrow it all the way down. On Wednesday, we're going to finish this section. The last 4 problems are going to be like this, just more in depth.